Okay, so now that we know certain values of sine and cosine, let's make a table of values that can be graphed. And we're going to be working in radians, okay? So we kind of need to know that, 0 radians is 0 degrees, 90 degrees is pi over 2, 180 is pi radians, right? 270 is 3 pi over 2, and 360 is 2 pi radians. So we kind of need to know that, right? If you get confused about that, let me know, okay? So let's fill out this chart. Now these are in radians, and if you're going to try and do this on your calculator, you will have to switch to radian mode, okay? So let's think about the cosine of negative 2 pi. Wasn't that just like negative, good God, negative 360 degrees, right?
Yeah.
Which is equivalent to 0. You guys remember the cosine of 0? We're on page 195, by the way, if anybody's wondering. 11.7.
Cosine of 0 will be just 1.
Is 1,
Yeah.
right?
Yeah, 1. And the
Okay.
sin will be 0.
So the negative 3 pi over 2, right? Wasn't that negative 270?
Yeah.
And what was the
So
cosine of
the
270?
cosine will be negative 1 then.
Well, that's 0. And this negative pi radians is negative, these are degrees, negative 180 degrees. Do you remember the cosine of 180?
Cosine 180 would be just 1, yeah. Negative 1.
Negative 1. And negative pi over 2, that's negative 90 degrees. Remember the cosine of negative 90? It was 0, right? And the cosine of 0 was 1. Let's just go through this, right? And now we have positive 90, right? Positive 180, positive 270, and then positive 360, right? You notice there's a pattern here, by the way?
Yes.
1, 0, negative 1, 0, 1. What do you think is next?
Also, you forgot to write the
0.
negative 360.
No, it's 1.
Oh, okay.
All right.
Hmm.
Look at the pattern we got. What comes after negative 1? 0, and then
0. Then
1.
just 1.
Okay, let's go down to the sine of x, whatever the x is, whatever that angle is. The sine of
So
negative
sine
2
will be
pi
0.
will be 0. The sine of negative 270 is 1, right?
0.
And then 0,
Then negative 1.
negative 1,
Then 0.
0, 1, 0, negative 1,
0.
and 0. You notice that the sine and cosine kind of alternate? And what do you notice about the maximum value of either sine or cosine?
The maximum value would just be 1.
1, and the minimum
1
is
and 0.
it never goes above 1 or negative 1, unless we do something to the equation, right? So let's graph this. Let me actually put, pause this a minute. All right, so there's your sine curve. Let me go back and let's plot that, and we'll make our own sine curve. Okay? So notice we have negative 2 pi to pi. That's negative 360 to 360, right? Move this out of the way. Okay? So let's do the sine first. Okay, let's do sine. So negative 2 pi, we're at 0. You guys can plot these, right? At negative 3 pi over 2, we're at 1, right? And then back to 0. And then negative 90, we're at negative 1, right? 0, there, 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 and there. And let's sketch in a nice smooth curve here, right? It's not going to be straight lines. God bless America. Keeps doing that to me. So we're going to go up here like that. I just lost track of my hand got in the way. Okay? So here is the graph of y equals sine of x. And we could not do that before because we could only do the sine and cosine of numbers between 0 and 90. And here we are going between negative 360 and 360. All right? Let's try the cosine one. We do that in a different color. Okay? So now, at negative 2 pi, we're at 1, right? And then 0. And then negative 1. You follow me? Once you get the first few, you can kind of see how the pattern goes here, right? Like that, okay? So this one kind of looked like that, a nice smooth curve, if you will, through here. And then like that. So notice they kind of invert of each other there, don't they? They're what's called out of phase. So this is y equals cosine of x, and that's that graph. Notice how they both have maximum values of 1 and minimum values of -1, okay? So most commonly, you'll see this part of the sine curve out in real-life applications, that positive part there. And that is the function, right, that models alternating current, AC, that comes out of the law, right? Because it goes positive to negative, to positive to negative. That make sense? Okay.
Sure.
Sure, but you sound like I lost you. If I've lost you, stop me. Could you make that table and plot this graph out and sketch a smooth curve? Brooke? Assuming that was Brooke that sarcastically said sure.
No, that was me. I was talking to my sister.
Oh, who's me? Is that Kelsey?
No, it's Olivia.
Olivia. Okay. So not a sarcastic sure. All right. Well, let's do real quick the domain arrays. We already kind of talked about that. The domain is all the x values, right? So we're out of the right triangle. Do we have any limit on any angle we can put in here now?
Yes.
No.
Oh,
We
no,
can
no,
do it.
sorry.
We can do sine and cosine at any angle. So an
Okay,
angle,
like
it's all
FND.
x, such
And-
that, remember how this works? X is just an element of the real numbers, any of them, right? And what about the range, the y values? What was the max and min? 1 and -1. So all the y values are between, right? -1. So remember this, -1, less than or equal to y, less than or equal to 1. Right? Sine and cosine go between -1 and 1. All right? And again, this applies, and by the way, does anybody ever do any audio work, like sound waves travel in this sinusoidal type curve? Anybody into music or like work with Mr. Doherty? Who works with Mr. Doherty? With sound stuff. They take his class. This is like music or something, right? What do you think? What do you think music, the sound that comes out of an instrument is? It's a sound wave that can be modeled by these sine and cosine curves, right? It's vibrations. Doesn't that look like a vibration?
Okay. Yeah, so it's like a wave.
And they have a frequency, right? They have a frequency. The frequency will be the number of times, right, that curve shows up in that distance. And remember, the higher the frequency, the higher the note, right? Does that make sense? So they have a period, it's called. So we'll get into period a little bit later. But the period of that function actually just goes from here at 0 out to 2 pi. See the red one, the sine curve? You see we get one full sine curve in between 0 and 2 pi, right? So we could say that the period, right, equals 2 pi radians, right? Which of course is 360 degrees. So one full sine curve comes in the period, right? Now frequency, as it turns out, is 1 divided by period, by the way, right? We'll deal with that later, okay? So the frequency would give you like the pitch, right? And amplitude, isn't that the volume of the sound? Amplitude would be how high or low it goes. -1 to 1 in this case, until we change things. All right? Let's look at some examples here on the next page. So now we know how to graph just the basic sine and cosine. Let's modify them so we can get different amplitudes, right? Different frequencies, periods, okay? Let's look at the next page. So we start dealing with a little bit of sound. So you see what's graphed there, right? That graph is the cosine of x, right? Standard cosine x. Everybody with me on that? It's like the one we just graphed. Now they want us to graph y equals 3 times the cosine of x. Well, that will just take every value we have there on the y part and multiply it by what? 3.
By 3.
So instead of being 1 this point, the point will become what?
3.
3. This will still be 0. Instead of being -1 here, this will be -3. You with me? Right? That'll still be 0. And then this point will become +3 because we multiplied it by 3. And we can go all the way back to the left side here, right? The -3 and then 0 again. Instead of 1, we got 3. So if we multiply it by 3, we get a nice modified cosine curve. That basically, you know what that means? We're talking about sound. If we multiplied it by 3, we just turned up the volume knob, didn't we? Notice it has look guys, it has the same period here in frequency. It still shows up one time in that period between 0 and 2 pi, right? But what's different? Like its strength, right? Its amplitude is different. So this is our y equals 3 cosine x. All right, what's the other one? Now we're going to take the original cosine and multiply all those values by what?
-2.
Okay, so instead of being, I'll use green. Instead of being 1 here, what's 1 times -2?
-2.
-2. And then 0, right? And this one becomes, the -1 becomes a +2, right? And then 0 here. And that positive one becomes a -2, right? It just keeps repeating the pattern. With me on that? And that's 0, and then down here to -2. All right, so let's sketch this guy in here. So we went from here, we're going to go like up through here, that. And this is y equals -2 cosine x. All right. Anybody have any questions on that? We took what they have in the black there is just regular cosine x. And then we had one where we multiplied that by 3 and the other one by -2. And the frequency stayed the same, right? Both of these here, between here and 360 or 2 pi, the cycle only happens one time. So it's still at the same frequency, but if you're talking about like sound or audio, the amplitude got turned up. You turned that knob up and made it louder, but it's still the same pitch and frequency, right? That's like playing your horn louder. All right, why don't you guys take a second? You guys think you could try this here? We're going to take this sine curve. We're going to multiply it by 4 and graph it, and then do it. Good grief, this stupid idiot smartboard. Multiply it by 4, and then do another one multiplied by -1/2. All right, so everyone give that a try. Okay, so we got our points plotted. Let's draw a curve through it. Nice and smooth. No V's or anything like that. This takes a little practice. I'll tell you, it takes practice on a smartboard too. It's a different animal. All right, hopefully your 4 sine curve looks like this. So this is y equals 4 sine x. Okay? And the -1/2, right? Well, it's just going to change all the values to negative, and you're going to take half of it, right? Are we still starting at 0 here? I would say the answer is yes. But instead of being at
It'd be
1
0,
here,
-1, -1/2.
-1 down in here, right? Be down in
Yeah,
there,
that'd be 0 again, then 1.
and then
Then
0,
1/2,
and then +1/2,
and then
0.
we continue.
It's a cycle, right? It's cyclical. It goes in a cycle. Once you get the first few, you're good to go. and then there, right? So we turned the volume down on the speaker, haven't we? Right? We're half volume now. So now we're going to go and negative. That would be the equivalent of switching the two wires on the speaker, I guess. But anyway, so it'll be like this. All right, and here is y equals negative 1/2 sine of x. Okay? All right, and so there you have it. Is anybody completely and totally confused right now? Say something. We can go back. We're out of the right triangle now. We can do sine and cosine of any angle you want. You can do tangent too, but not as useful. So we're going to dispense with it. All right. Let me give you your problem set. And it's not much. So your problem set are just going to be number 1, 2, and 6. 1, 2, and 6. Okay. Anybody have any questions on this? This stuff is very, very handy out in the real world. If you're into audio or electricity or anything like that,